Hi guys, today I will be showing you how does the wings of an airplane work, like on my drawing, my horrible drawing. So let's imagine that this part of the airplane is one of the wing and it's going outside of the board. So I'll give you the popular explanation first. That is almost the one uh, that we assume that is the one that is okay. So this is under foil, and this represents the velocity. So the popular explanation says that over the aerofoil, the velocity is bigger, and under the aerofoil, the velocity is low, and upside, as Bernoulli's equation says, the pressure is smaller, and downward, the pressure is bigger. But why this popular explanation is wrong? Well, there are three main reasons. One is the distance, the equal time argument, and the Bernoulli's demonstration. I'll show you each by one. First, I'm going to start by this one, the distance. For the distance argument, I have to explain it like in this way. Imagine that have a boat with a sail. So let's see from the upper part of the boat the sail. So this is the mast and this is the sail. And what this distant argument basically says is that there is no need, the distance between the sail and the flow from the upper part and also from the lower part is almost the same distance from here to here. So there is no need of different distance around the upper and the lower part of the surface for generating a lift. So the equal time argument explains to us the movement of particles from one side to the other, and the popular explanation says that they arrive together, but that is barely true. And I'm not got good drawing, so I'll put here an image of a study where they inject from a line. At the same time, the smoke and those particles were detected by the smoke, and they realized that the particles from the upper part of the that go from the upper part of the aerofoil arrived faster than those one in the lower part. So the fluid of particles traveling along the surface that go from the upper part arrive before those ones traveling along the lower part of the surface. So the Bernoulli's demonstration, it's okay, but I think that it's misunderstood. So I'll try to explain first why it's wrong. The application. So downwards the, I don't know, let's say it's a paper, the pressure is bigger and the velocity is small, so this makes the paper go up, and the velocity from the top is bigger and the pressure is lower. So that makes that this is only valid if the paper is like horizontal, but let's put it in this way, with a paper that is straight, the velocity from the other side and the velocity from this side is bigger than this side. So does it really matters? No, because it doesn't affect the curvature of the paper. So it's independent of the velocity, the curvature. So we can make a connection between the flows in the two sides of the paper uh, for the form of the paper, for the curvature. So what is true about all this popular explanation? Well, the truth is that of Bernoulli's equation is a force acting on a streamline. Let's say the streamline is a paper, the wing, something. So pressure, we know that is a bunch of molecules hanging around, and in this case, in the upper part, they are more dispersed, and in the lower part, they are like more together, and but they are hanging around, and they are traveling to any one place. But it's not hardly true because they they are moving towards a motion. So if they are moving towards a motion in this mass, maybe they are moving in around a centripetal um, centripetal force. So let's say they are moving in a centripetal force toward the motion, and they are like just moving around, pushing and pushing. So that's the main force acting on the streamline. So this means that this force of pressure drops along this streamline and increases the velocity, and the other way around, the velocity decreases as long as the pressure is not dropping. Another way to explain this centripetal force of particles is with a tornado. Um, so in the center, the pressure drops down, so in the center there is no pressure. So the alternative explanation of a lift, I think, is the main popular explanation, but in is more detailed and is using the appropriate concepts to explain it. So from from this point to and the other point, as they go to the center, there at first there is no pressure gradient, and they tend to make a curvature. So from example, from this, the curvature is not that much, but as it gets near to the center, the curvature gets more and more curved. So the form of the paper of the or the wing, uh, anything. But from the point A from point B, we can see that the pressures are different. The pressure is more at point A and it gets lower at point B, and the other way around from point D to point C, from point C to D, the pressure is lower and is starting increasing, which it gives us a resultant force of pressure that is making the airplane going upwards, making possible the lift. So these alternative explanations tells us that this resultant force of pressure is directly proportional to another force of suction. And this has to deal with Newton's second law of, for example, in a free body diagram of an object, we have the weight and the Newton and the normal. So they are directly proportional as this example. A common question is how do airplanes manage to make a donut in the air while flying upside down? Well, the answer is that there's a key concept that is called angles of attack that influence the lift of the airplane by what we were talking about, by the wings. So there are different types of angles attack. One is low, high, and subtle. So the first one, the low, is like the normal one that the flow covers like up all that part of the airfoil, and the second one barely crosses the one part of the airfoil, and the other one doesn't join like at all the the end point of the airfoil, so that makes the airplane uh, able unable to have a lift. Another common question on wings is why the wings of an airplane are that huge and not like a thin and lovely thing, cure that might be more able to do a lift, but the main reason is because of the useful part, because they're made for storage gasoline or some luggage, and that's the only reason. But if you have like a simple wing without any compartment to store things, it's also useful because it's going to be easily lift.